in the back, then diamonds, then clubs, and then hearts. And you're trying to do this as fast as you can as a group, so make sure everyone participates. So stack the deck together in the center of your desk.
Only one deck of cards, right?
Yeah. Hold on, don't distribute them yet. Stack them in the middle of your desk. So everyone starts together.
Don't mix both decks together.
So put the decks like face together and then face down in the middle of your desk.
Face down,
Something in the middle of your desk. Face down in the middle of your desk. All right. Does anyone have any questions before we start? All right, let me get the time ready. So make sure try and get everyone to participate in your group. You're ordering ace to kings for each suit, and then spades, diamonds, clubs, hearts from back to front.
Do you guys want some time to strategize really quickly? Yes. Yeah.
Wait, we're supposed to do it cold. We're supposed to do it like cold so they don't know. Yeah.
Okay.
Wait, we have to wait in the lowest amount of time possible.
Yeah.
Wait, it's a race.
Ace to K. So ace is in the front, K is in the back. All right, you guys ready? Yeah, question.
So all right, we have them, let's pretend we have everything in order. Does it matter what order the suits are in?
Yes, spades are in the back, then diamonds, clubs, and then hearts will be the ones you see at the very front of the deck. All right, ready? Set, go. Start.
Hearts, spades, your clubs, hearts, your diamonds.
And when you're done, just like raise your hand and say ding, ding, ding or something.
Take this
Oh. Oh, do you want to buy AT&T Wi-Fi?
Wait, I'm missing the two. I'm missing the four. Oh, found it.
Okay, spades are done.
Didi, wow, it's so rude.
Oh my god, I'm so sorry. They don't have
three of them.
I'm missing a nine.
There's no three.
I have a heart.
There's no three of spades. Oh, it's like this?
Yeah, it's over here.
Here you go.
Okay, I'm done.
Give me diamond.
Okay. No, that's not diamond. Diamond.
Goes last, right?
Done.
Oh. 125. Your dank memes?
Alright, we're done.
Fried jacks.
Yeah, fried jack.
Oh yeah, yell your name. It might help. Thank you.
Yeah, Jack. Let's check.
No, I don't fucking have to.
Ding, ding, ding.
Alright,
Bingo.
Shuffle.
Bingo.
Yeah, okay.
All right, so now that we've gone through it once and you guys have a bit more, experience with it, and we're going to give you like a minute or two to strategize and actually split things up, however you want to, and then we're going to do it again and see if you guys can beat your old score. Yeah, please reshuffle them.
Shuffle.
10 seconds. Oh man.
We're keeping the same strategy because it worked efficiently until the point where we got mixed up.
Yeah.
So, what we should really move seats. Because me and her are both red, so it makes up the problem.
So same strategy?
It might be the hearts of space.
All right, and then after this, we ask them like to share their group ideas.
Yeah. Say us close.
And then we go in one more time, right?
Yeah.
And then discuss, and then we do the correlation.
What's the order again? Yeah. Oh, I was there.
It's you see the ace and then the back. Yeah. Jack, queen.
Jack and queen is the best. It goes 10, Jack.
Even that joke. That's the part I like best.
Yeah. That's what I do.
Are you guys about done? Yes.
All right.
Okay.
All right. So get the cards in the middle of your table again. Oh.
Yeah, it's a sack.
All right, let's see. No. All one. Everyone starts equally. All right.
Hey, it's strategy. Leave me alone.
All right, and remember, try and get everyone to participate. Make sure everyone's included. All right, ready? 3, 2, 1, go. Name. Oh my gosh.
Right, Jackson. Right, Jackson. No, you messed up. This is
Yeah,
the
no.
first one is this one.
Okay,
This
this was the first one, right?
This one didn't end yet.
Yeah, no, it's really faded.
You done? Okay.
All right, so, it was really faded. Okay, so do you guys want to share maybe some strategies you guys came up with maybe between the first and second rounds that your group felt effective?
A magician never tells her secrets.
Oh, okay. Does anyone else want to maybe throw out what they thought maybe was an improvement from their first, or you could talk about your first strategy and maybe why it didn't work. That way it's not you revealing your tricks.
So you broke up into groups, and then what did that do for you?
Assigned each other.
Okay, so distributing the workload. It's not all one person doing something. Okay, anyone else?
We started them out by color first.
Yeah, so maybe taking intermediate steps and sorting it so it's easier to handle.
Did anything not work for you guys?
Well, we were fun doing for the cards, and we didn't know who was doing what.
Right.
All right, so we're gonna do it one last time. Ideally, you guys all shared your strategies and you learned from each other, but it's okay this way too.
So stop. Watch.
There is.
So yeah, you can do the last.
Oh.
Organize your life without ever looking for another person. So let's pretend these are the 4 different types of cards. You keep yours to closest to you, and then you organize the rest. And then, all right, grab our decks.
All right, guys. Get the decks in the middle of your tables, and then we're gonna get ready.
Come on, Barry.
So what do we do?
Hannah, put your hands in. Count 3.
All right. Ready? 3, 2, 1, go. Can you get a more visible pen? Actually, do you have the email? Oh yeah.
I got mine. I got mine. Here.
Don't do this.
Where is the other?
Take
Where are
names.
the other clubs? I mean, not clubs, I mean. Wow.
Well, that took longer.
Oh, this is seconds.
30 seconds.
So I think I put the colon here in the wrong spot. Let's just forget about that.
Oh, okay.
I think we're all done. All right, so, oh wait. Oh, whoops. I thought they were already done. All right, so, do you want to go ahead and talk about it?
So how many people were in your group? 6, okay. I can just count them. 6, and then it was 4.
Yes.
All you did was like move,
And then-
drop the first card.
Hold on.
And then 5.
I'm just gonna rewrite this.
Alright, so you guys can see that you progressively, sort of, the majority of you got better as you guys strategize and refined your strategies. And then what we want to do now is kind of show you the relationship between the number of people and your speed. I wonder if there is actually a relationship. So do you guys were the biggest group. Did you think that was easier having a lot of people, or was it more complicated? Thoughts?
It was kind of both.
Both? Okay.
Lots of hands were
Yeah.
just interlocking with each other as the cards were sorted out, and so it got in the way a bit.
In terms of your score, you guys did decently well. Okay, so for the fastest group, number commitment. Why were you guys the fastest? You guys.
Oh, for the last one.
Yeah. What do you think? Why are you guys so fast? At the very end.
They didn't shuffle it.
They looked for polls and instructions and were able to succeed that way.
Interesting. Okay.
Yeah.
Would you care to share those loopholes?
No.
If it's to keep the sack as it was, or it's like 2 cards.
Why were we so fast the last time, Joshua?
We did it at a faster pace.
Shocker, would you like the lights? Shine the light on?
Observation, I'd say you need to add to the instructions that they have to shuffle at least a couple of times.
Oh, okay. Okay. It's okay. It's good. It's good. Well, we're learning here too. All right. All right. And so the idea, aside from this loophole here, the idea was that after you guys all learned or were able to discuss your strategies and kind of learn the best way of doing it, you guys came out with very similar times, right? So everyone was almost exactly the same at 1 minute. And the idea here is that at some point getting more people in the group doesn't necessarily make it better. The reason that So computers have been getting faster and faster over the years, and another thing that has been improving is just, I guess, our ability to be very efficient with large amounts of data. And so nowadays what we can do is we can take one program and split it across multiple computers, and everyone can work at the same time and make it go by a lot faster than one person can. So do you guys think you could have gotten this time if you were working by yourself?
Probably.
Oh man. Well, you can go for the world record. It was 36 seconds, so actually we were pretty close here. Yeah, but so basically the idea is that, yeah, it's good to like get into groups and work together towards the common goal, and that'll make it faster. But at the same point, there's, you know, a certain point where it's too many people, like they were talking about here in dank memes, you know, arms are crossing, you just kind of, everyone's getting in the way. But yeah, this idea that you're splitting up the work, and then you're figuring out like smaller steps in between from the beginning to the end. Yeah. All right. So with that, we're going to go on to our next activity. And okay, I'll be the one passing it out, and then, oh, okay.
Yeah, okay.
Would you like one?
No,
Okay.
good, thanks. All right, okay, so now we're going to do something
That.
paper. You'll notice that your first habit, nursery rhyme.
Would you like one?
Thank you. No, you have this, right?
I'm on my way. I'm on my way.
Pitter patter. You can say that again?
Listen to the rain.
Okay, so, how am I supposed to introduce this?
Just talk about what the topic, so the idea of compression, and then.
So we're supposed to show them the video first?
Oh yeah. Feel free. So actually, we're gonna watch a video really quickly, if we can get it working for you guys. But here are some very sharp pencils. All right. So as we're getting the video loaded, I'm gonna talk a bit about this. So the next exercise is an exercise on compression. And so nowadays we tend to send a lot of data over the internet. You know, that's a lot. Like if you're going to send a big letter to your friend, a Word document, or like a video, it takes a lot of time for that data to go from one place to another. And so what computers nowadays will do is they'll look through the data and try and remember things they've seen before. So for example, here on your paper, you have the word pitter patter. If you're sending this across the internet, it probably won't take that long actually, but it might think, okay, let's see, I see that I've seen the letters ER before, I'm just gonna remember that, and next time that comes up, I don't have to remember that, I don't have to send ER again. I can just send a special encoding that says, oh, okay, look here instead, and then it's been repeated, we've seen this before, and so it shrinkens the amount of data that you're sending across the internet. So it makes things smaller, that's why it's called compression. And then, yeah, so this is a key idea, I guess, in computer science nowadays because you're sending a lot of data across a lot of places. So hopefully we can get this video going. Do we have enough time?
We can make this kind of short.
Oh, can you pull it to the, yeah, there you go.
One of the root causes of the shortage of computer science graduates is simply the difference between what school students perceive computer science to be versus what a computer science graduate actually enters.
Is there like a sound button?
If you ask a school child what a computer scientist does, they might say fixing computers,
Oh, thank you.
Or maybe computer programming. But of course, computer science is a lot richer than that.
Oh, here.
Why just a little bit more?
All right, maybe it was just.
In the 1 hour show that you're about to see, 2 computer science graduates are presenting ideas from computer science to children who are about 12 years old. We hope that you'll get ideas from this show for running your own presentations. Oh, by the way, it doesn't use computers at all. As Dijkstra said, computer science is as much about computers as astronomy is about telescopes.
So all we're going to do now is wait for my faithful assistant Harv, who is running late. So just wait patiently, and we'll get things underway very shortly. Oh, hey, Harv.
Me and Arnold, sorry, we're late.
That's good.
Are you setting up for the show?
Yeah, it's all set up.
Where are the computers?
What computers?
The computers computers for computer science?
Well, we don't need computers to talk about computer science, Hub.
Arnold says you do.
Well, Hub, it's like this. Computer science, it's just science. Computers are just
Time was fast.
But computer science?
Yeah, but it's like, I don't know, when you're looking at stars through a telescope, what do you call that?
Astronomy.
Astronomy, right?
Yeah, yeah.
It's not telescope science. Telescopes are a tool, and so are computers. And what we're looking at with computer science is information.
All right. Arnold still finds this hilarious.
Well, Arnold, would you like to see a trick? I'd like to see a trick. Good. Excellent. Okay, so we're going to need a volunteer for this trick.
A volunteer? I can totally choose a volunteer.
Yes.
Hey, what's your name?
Yes. Brittany.
Brittany, good. Can I try to help you, Brittany? You guys want to give her a hand?
Now, Brittany, so what you may or may not know is everything on a computer is stored using one of two numbers, right? Either 0 or 1. So what I've got here is some cards, and we're going to use these cards to represent 0 or 1. Okay, so the black side is going to represent 0, and the white side is going to represent 1. Right, so what Harv's started doing for you is we're putting up a grid of these cards. So I'd like a 5 by 5 grid, please. Now, I want you to put them up any way over you like. Don't make any patterns, because what I'm going to do is I'm going to try and memorize them. Okay? So I just want you to put up like that 5 by 5 grid. Those black and
Maybe
white
at the end
cards.
of
Like a square, yep.
I'm going to trust you. With the power of my mind. There you go.
Think. So yeah, so while Brittany's doing that, what we've got is a bunch of zeros or ones. So does anyone know what a 0 or 1 is called on a computer? Yes. Binary code. Yes. So 0 and 1 are numbers. They're digits on a computer. So you guys are used to a different set of digits, the digits 0 to 9. But we use binary digits. So does anyone know the short name for a binary digit? Yes? Not quite. I'll just do this. Yes, that's right. How are we going there, Brittany?
Brittany's run pretty well.
We going pretty well?
She's faster than I ever could.
Okay, well see the thing with that is it's only 25 bits. So I'm going to make things a little bit harder. I'm going to add an extra row and an extra column.
You're crazy.
I'm going wild with excitement. Listen to the crowd, they're going mental.
And the crowd goes mild.
Super. Okay. Just throw some of these extra bits on it there. Great. Okay.
So what's the trick?
So, it's not really a trick, it's just science. But what I'm going to do is I'm going to turn around in a second and I'm going to get Brittany to flip over one of those bits. Now, we've never met, have we, Brittany? There's no possible way that you could communicate to me which one of these bits you flipped over. I'm relying on the power of my mind and the power of computer science. Okay? Alright, so I'm going to turn around.
Don't let him fool you with his black magic, Brittany.
I'm going to cover my eyes. You guys are all going to watch me to make sure that I'm not looking.
I'm going to put a
Watch
mark
Brittany
on
to
the
make sure
flips.
that she's flipping a card. She's going to put a mark under the card that she's flipped over, just so that we know that I've got it right when I eventually do get it right using the power of science.
We accept.
Alright, are you ready?
Yep.
Okay, good. Let's see, I'm going to guess that it is this one here.
Fluke. Fluke.
Alright, I'll do it again.
Do it again.
Okay.
Make it hard, Brittany. Oh God, not that one. No. Anyone you want. Except that one. Stop it. Do it.
Okay.
We accept.
Alright, now there's 36 cards up here. There's a 1 in 36 chance that I'll get it right just by accident. And there's a 1 in whatever 36 times 36 chance is that I'll get it right twice in a row by accident. But I'm going to guess this one. No! Alright, thanks Brittany.
We should the explanation.
Brittany likes to giggle.
The
So
explanation.
that's my trick. So on with the show then.
How did you do that?
Well, I use science.
Lad?
You want to know the secret?
Yeah.
Well, sometimes scientists have to learn that there are some questions that they don't know the answers to. And it takes a long time before people can figure out those answers.
Whenever you'll tell me later.
If you're good, I'll tell you at the end of the show.
Fine.
All right.
One of the key techniques is that we're trying to draw the answers out of the children. We're not trying to actually teach them the concepts. We just want to be able to give them confidence that they might have come up with the answers themselves. Now that we've looked at storing zeros and ones, well, so far it's just black and white cards, we're going to look at how we can group those zeros and ones together to represent data of various kinds, starting with binary numbers.
Is that all? Oh, okay.
Okay, cool.
That was our first time watching the video too. Yeah, okay, so let's just get back to the encoding here. So basically what we're going to ask you to do is basically do what I talked about earlier with the encoding, which is you find groups of letters or phrases or words that are repeated in the poem. And so basically, for example here, I have pitter patter, right? And so I noticed that this ER and this ER happen more than once. So I'm going to box the first one, box the second one, and then draw an arrow that says, oh, I've seen this before. I don't need to send this again. I can just send this box instead that points to this previous one. And so basically just go through the poem, maybe as a group, and just see what you can find that has come before and just draw boxes.
Or even for this first one, you notice that you can actually include the TT, right? Because the TT is also repeated. So you can take that whole box of things instead and do the same thing.
Yeah, so feel free to work, talk. I think we should show the video. Oh, thank you.
Throw away that one that's
Oh, the
no
purple?
good.
Yeah. All right, thank you very much.
Well, fill that one out. But so you can use what you learned from here to do this, box it out, what is repeated. You can do entire lines, but it has to be 2 letters or more.
Just like 2 minutes. Yeah, 'cause- How are you guys doing?
Yeah, I'm not like
Vanessa, should we just like get together and then go over it?
Sure.
Okay. Because I'm kind of worried about time. Okay.
Let's finish just the rain.
All right. Yeah, we have to do the porch one too, though. All right. So I'm just gonna ask for suggestions. Like, well, okay. All right, so why don't we get together and see what people came up with. So we have this lovely copy of the paper on the board, And does anyone want to share maybe repetitions that they found throughout the poem? The TTER. So we have this, and then which line? All of them? Okay. So basically, all these TTERs, like he said, were repeated from this first one, and then we can just assume the same. Anyone else have any suggestions?
There's 4 lines in which it says pitter patter, so copy 3 of those from the first one.
Right? So you could say this whole phrase has been seen before, and just be like, boop. Okay, any others?
The other 2.
Yeah, etc. Oh, whoops. Okay. Anyone else? Suggestions, ideas that you came up with?
The and
The and the. So yeah, that's a really good one here. Anyone else?
Rain. I don't know the title.
Oh yeah, that was a clever one. That the rain. Oh, the rain. All right. So we, the instructors, actually worked on this the other day, and we came up with a few. You can actually take the entire pitter patter, and say, "Oh, I've seen this before." And then, what are some other ones that we found? This pa in pain. We can say, "Oh, we've seen that in patter." Yeah. So. Basically, this is like what we talked about, which is compression. So we're trying to find things that we've seen before, so we don't have to copy the entire thing over again. We can just say, hey, just look up here, and then it happens again. So we're going to send like all these empty boxes that point to other places across the internet to someone else. But if we don't have a way to read it, like there's no way to interpret it, then it's kind of useless. And so that's what this part down here with the P's and the por is showing you here is you can also decrypt a message or uncompress a message that has been compressed. And so we're just going to work on that and see if you can fill in the boxes here. It's the same thing as you guys just did. If there's a circle on the box, it means it's the same thing as whatever the arrow points to. And so, unless you guys have already done that. Oh yeah, it looks like you guys... No? Okay.
They're okay to work on the back?
Oh yeah, feel free. I don't think we'll have time for the back.
Alright,
But.
cool.
Oh jeez, that's almost done. Everything okay? Mm-hmm. Nice. How you guys doing? Doing all right? Need any help? Questions? We can. I think some people are still working. How are you guys doing on the porridge question? You good? Did you guys have any questions or no? Okay. Does anyone want more time for the peas and porridge? No? All right. Well, I guess we'll just move on then. Okay. So yeah, that was basically uncompression. So the message you would get from the peas and porridge is all the letters that are there. Notice how there's a lot of boxes that are pointing to other places. It's a really short message. And so it's a lot shorter than the entire message that's been uncompressed. And that lets us send a lot of data across a large place, or just across the internet, and then do it very quickly. So we're going to move on to the back. So maybe we'll have time for questions at the end. So basically, you have something called binary. Or should we talk about binary? Okay. Did you want to talk? Or?
I won't talk about binary then.
Oh, okay. That's fine. That's fine. That's fine.
Okay, so for the back, you see that there's, okay, when Deb gets mad, she sends her friend a have encoded messages using lines of pennies, each of which is either heads up or heads tails. Tails up, I mean. An example is that random line of T and H's. So this is a bit like the binary code that they were talking about in the video, how binary code just uses 1 and 0. So we're trying to replicate that here with this H and T. So we're going to go through the first example at the top right here. So we have T, H, 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 T, H, T, T. Let's first decode that one. So does anybody have some idea as how we can approach this using the tree we are given? Yeah, basically that's it, right? So let's start with T, which leads us to H, T, H, H. And then you get B, right? So you can section off that first 3 THH to get your first letter. So you can just continue doing that. And does anybody want me to go over more of that? Or you guys got it? Good? Okay. Then why don't you guys can start doing C1 then?
Sure. Anyone have any questions? Did you have any? Yeah.
How would you get there?
All right, so you start at this dot, right? You go down, and then you look at the first letter. Right, and it's a T, right? So you follow it down to here. Then the next one's an H. So you follow it here, and then the last one's an H. Right? And as soon as it hits a thing, you can say, oh, that's the end of that letter, and just start. So do you kind of, so for A, obviously, it's just an H, right? Yeah. Nice. You guys have any questions? Been good? Nice. You guys doing okay? Okay, perfect. You guys doing fine?
That's why you give out words like this, so we can work out.
Then feel free to move on to the second line if you haven't already. It's supposed to be an actual sentence.
He fed beef. Well, I got wait.
Oh. Yeah, there you go. It's kind of hard when you only have like the first 8 letters of the alphabet to work with.
It's like the E.
Oh, you missed the D there.
That I cheated with that one.
No. It's for you to take home if you want. If you could also recycle it, environment.
So a little bit more on the importance of the significance of this encoding and whatnot. Why we had you go through these exercises is that there's a lot of text in the world, right? For example, newspaper articles. I don't know if you guys, I don't read that much newspaper online, but anyway, that have a lot of text, right? So how would the computer, if they had to send all those text with no repeats like we did, no memorization like we just did, then that would take a lot of memory. And I guess you can store that all on the computer, but eventually your memory would run out. Which is why computers can memorize certain sections that are repeated to decrease the amount of memory space they have to use. And also, yeah, I think that's it. It's important. Oh, and let's say you had to send an attachment to your friend for a project. And if you had to send an entire file without doing the encoding stuff that we just did, that would take a lot of space. Probably your email won't be able to send it over, which is why what encoding does is minimize the amount of space that is needed for you to send text over to somebody else.
So the sentence, actually, do we have a solved version? Actually, I'm just going to borrow this over your shoulder. The solved version should be, he fed beef a caged bed. And so it doesn't make the most sense, but we only have 8 letters to work with. And so yeah, hopefully you guys got that. So with the remaining time, I was just wondering if you guys had any overall questions about anything that maybe we could answer for you guys. It can be hard if you want it to be, really, because you get to schedule your classes per semester and you get to pick the extracurriculars you take. So it's really up to you to make your college experience however you really want it to be.
Have you ever pulled in online?
Yes, I have. But just if you stay on sometimes you fall behind. But if you try and stay on track, you probably won't have to fall on it.
Do you go to frat parties?
I don't. I mean.
But they do have them.
They do have them. Yes, they exist.
So is your social life greatly changed, affected by college?
What I found is that you do make a lot of new friends in college, and since you spend a lot of time, on campus and with all these new people, depending on what college you go to, you do tend to get closer to these people that are on college as opposed to people who you met in high school. But that's just me. If you put in the effort, you definitely can keep in contact with the people in high school. But you definitely make new friends and have a new group of people to talk to as well.
Computer science classes? Or just in general?
Just in general.
So they recommend taking around 13 to 14 to 15 units your freshman year, which is around 3 classes or so.
Okay.
3 to 4.
3 or 4.
And a lot of times they'll have advisors, and they'll talk to you about how to set up your schedule.
Yeah, you definitely would get advising.
Yeah, they don't just throw you in and be like, hey, welcome to college.
I heard you can't get into college if you have a D.
No, well, there's a lot of different things, right? They look at your GPA and they look at your extracurriculars and then they look at your scores at the standardized tests. So yeah, you can get a D. I mean, it'll make your GPA go down, but if you can keep up that GPA, maybe you retake the class and get a higher score. They look at a bunch of different things. Just make sure you check what college you want to go to and see what requirements that they have.
And write about it in your essay. Write about if there's some reason why you got that D.
Because I have 2
something
AP
that was
classes.
going on.
Work hard, work hard.
One B is
Okay, guys, we need to go on to the next.
Oh yes, please. You can leave them there and then we'll pick it up. Thank you guys. Thank you.